So as a matter of fact, the big thing today is called special parallelograms, which again is why you had to be here yesterday to know what a parallelogram was. Anyway, what are geometric properties of rectangles, rhombuses, and squares? What information about a parallelogram allows you to conclude it's a rectangle, rhombus, or a square? Woo! Proven apply properties of rectangles, rhombuses, and squares. Use properties of rectangles, rhombuses, and squares to solve problems. Prove that our given quadrilateral is a rectangle, rhombus, or square. We need to know rectangles, rhombuses, and squares. So first thing you need to know, it says second type of special quadrilateral. Just ignore that for now. Just put this. A rectangle is a quadrilateral with 4 right angles. A rectangle is a quadrilateral with 4 right angles. You don't even know that half the story. I'm now off 25 pounds. I got married. I gained 30 pounds because one of the things that happens when you go from being a bachelor, living off of Google is to getting married and your wife likes to bake and cook all the time. Is that she doesn't know how to make things in small portions. So she makes things in dish size. It means that there's all this food available at our house. And then the other thing, I told y'all from school. And so, start writing this down too. I'm in school too. So when I'm in school in the evenings after I get done teaching, I go to Atlanta to school. And my wife last year, our first year married, she wasn't in school. She would stay home, and every Thursday she made me a cheesecake. For our first year, like from starting in August through like December, every Thursday she would get on Pinterest. Yeah. So it was my wife's and my belly's. And then we got to talk at Christmas, and I was like, listen, I am going to die this time next year if we don't slow this train down. So she had to stop making it. One of the whole we saved about cheesecake because we weren't making money on, cheesecake recipes the whole time. And now she's back in school, so I'm pretty much back to the robin.
But it's pretty good about
that is thinking of her, but my problem is it's so good that I just eat it all night after night, okay? She's like, there's some men, and listen, this isn't to be mean to anybody, but hey, someone who can't cook, that's okay. There's nothing wrong with that. My mom can only cook chicken. Okay, so I had chicken every night growing up. My wife can cook pretty much anything, and it's really good. So some men starve their first year of marriage because their cooking is very good. My sister, terrible cook. My brother-in-law lost like 80 pounds. Okay, he was awful. He was really neat. Not me. I got left. All right. Properties of rectangle. If a quadrilateral is a rectangle, then it is a parallelogram. If a parallelogram is a rectangle, then its diagonals are congruent. Whoa, dog! What did you just tell me? Yeah, that's right. If we have a rectangle, then we have a parallelogram. If we have a rectangle, then we have a parallelogram. So all the properties we talked about with parallelograms, they get associated with rectangles. So wait, before that was a big one, okay? You just need to write this down. If it's a rectangle, then it's a parallelogram. But let's talk about, remember those 5 properties we said? The opposite sides are congruent, correct? The opposite sides are parallel, correct? I know. Okay? I'm sorry. this is where you got to think about it, all right? In a rectangle, Miss Love, this is your chance. You ready? Are the opposite angles congruent? Are the consecutive angles supplementary? Well, see, that was your chance. No, I'm sorry. Is it okay for them to be supplementary at the same time? Yeah, it only happens in 90-degree angles. You're close. You're very close. I'll give you another chance, okay? All right. So, that's crazy, right? That's what makes right angles so cool, guys. Not only are the opposite angles congruent, but the consecutive angles are supplementary. 90 plus 90 is 180. Yeah, 90 plus 90 is 180, and 90 equals 90. I mean, that's cool. All right. Here's the big one, Miss Love. We said yesterday that a parallelogram created bisectors of the diagonal, right? You cut them in half. Look what happens here. AC is congruent to BD, right? All right, so here's the big takeaway, okay? In a parallelogram, the diagonals have to be congruent to each other. From yesterday, did the diagonals have to be congruent to each other? No. In a rectangle, do the diagonals have to be congruent to each other? Yes, you may move forward. Okay, never mind. Then we get a rhombus. Yeah. All right, so it's like a square. You can't have a rhombus on the side of a rectangle because remember the difference in a rectangle and a rhombus is going to be the sides. So check it out, y'all. A rhombus is a quadrilateral with four congruent sides. Does a rhombus have right angles? Well, CPJ, that was a trick question. When a rhombus has right angles, we call it a square. When a rhombus has right angles, we call it a square. Alright. It's okay. Wow, I didn't come home. Nope, right faster. Alright, here we go. Guess what? If we have a rhombus, then we have a parallelogram. Hot dang. How about that? If a parallelogram is a rhombus, its diagonals are perpendicular. Whoa, that's cool. Perpendicular. What does perpendicular mean? Give me a better example of perpendicularity. Maybe this will help, guys. Oh, Miss Love. Perpendicular forms what kind of angles? Right angles. So even though this is slanted, I still have 4 right angles there. Okay? That might be something that you want to add to your drawing. Perpendicular. Finally, if we have a rhombus, each of the diagonals bisects a pair of the opposite angles. Okay? So, check it out. The rhombus is a lot, right? These angles are congruent. These angles are congruent. These angles are congruent. These angles are congruent. Bisecting the opposite angle, perpendicular. Man, stuff's cool. It's so neat. Just love me some rhombus. Okay. Don't write this down. Don't worry about this yet. Like a rectangle or rhombus is a parallelogram. You can apply the properties of parallelograms to rhombuses. All right. This is a helpful head. Rectangles, rhombuses, and squares, which we're about to talk about, are sometimes referred to as special parallelograms. Right? Okay. No, because you need to write this down. Square, quadrilateral with 4 right angles and 4 congruent sides. A square is a quadrilateral. How many sides does a quadrilateral have? 4. 4 right angles, 4 congruent sides. We're going to show that a square is a parallelogram, a rectangle, and a rhombus, all at the same time.
No way.
Right on. Right on. All right. That's all right. A square is a quadrilateral with 4 right angles and 4 congruent sides. Hey, stop. Hey, no, look. I'm weird. All right. Let's talk about. It's good at this point, I think, to complete a review, a full-on review of all these properties. We just added a bunch, right? Okay, first off, a square is a parallelogram. Let's go through all the properties we know of a parallelogram. Opposite sides are congruent. On my opposite side, BC and AB, are those congruent to each other? Yeah. Are BA and CD congruent to each other? Yeah. So I got that. Next, it says the opposite sides, both pairs of opposite sides are going to be parallel. We don't really know that just yet. We'll talk about why that's true, though. Okay? Right? Right? Are the opposite angles congruent? Both pairs of opposite angles are congruent. Are the consecutive angles supplementary? Yeah. As long as 90 plus 90 is a buck 80, yes. Okay. Finally, what do we know about the diagonals? They bisect each other, correct? Okay. I'll pull up on that because I'm going to show you something cool about a square. Right? A rectangle. 4 right angles. Do I have 4 right angles? Okay. And all of those properties of the parallelogram that we've already gone over, right? Also, the diagonals are congruent to each other. Okay, again, don't have that just yet. I'm going to show you what happens, okay? The diagonal. A to C going straight to the heart, okay? Or B to D. Right? Then we get to a rhombus. Okay? Let's check it out. Are the 4 sides congruent? Yep, the 4 sides are congruent. Okay, that's good. Then we get to some of the tougher things. Remember these properties of the rhombus. Okay? The diagonals are perpendicular. Meaning, and it's not going to be perfect when I do it by hand, meaning I've got 4 right angles right there. Okay? I've got 4 right angles right there. Y'all see that? Okay? And right now you think it's really small, but you look at it and you're like, okay, that's not a big deal. It's a huge deal moving forward. So those are right angles. Okay? Huge deal. The diagonals, and this goes back to the rectangle, right? The diagonals are congruent such that AC is congruent to BD, right? So I've got 4 congruent, well, I have 2 congruent diagonals, but A from A to here is the same as C to here, is the same as B to here, is the same as B to here, okay? That part's big as well. Finally, that last part, and this is where I tell you that don't just trust my words, not my drawing, okay? They are diagonals are the bisectors of the opposite angles. That means that it take a 90-degree angle and cut it in half in each angle, right? If it's going to cut 90 in half here, it's going to cut 90 in half here, here, and here. What is half of 90? All of my angle measures, they're 90 degrees total, but when they're bisected, they're all 45 degrees. Okay? What do y'all notice about the formation that's going on right here? What do we call that? What kind of triangle? Right triangle. Even more than that, we end up calling that a special right triangle, which is what we get into next unit. Okay? The hypotenuse is here. Okay. Right. This is hypotenuse. These would be the legs. Okay? And what we'll learn about 45, 45, 90 triangle is that there's a special ratio such that x times squared 2 is our ratio for 45, 45, 90. X times squared 2. We're not there yet. Okay? All right. Let's do this. I want y'all to do this one, write this one down, okay? I want to see how we can do with this. A slab of concrete is poured with diagonal spacers in rectangle CNRT. What type of shape is it? A rectangle. What is true about a rectangle? The angles are what? They're congruent, they're 90 degrees, right? Okay. CN is 35, NT is 58. CN is 35, and NT is 58. I want you to find TR, which should take you approximately 3 seconds. And then I want you to find CE, which is going to take you a little bit longer. Put a couple minutes on the clock. Let's see how we do. Okay, if I have a rectangle through a wall, that's a parallelogram. Okay, if a quadrilateral is a rectangle, then it is a parallelogram. In a parallelogram, opposite sides are congruent. So if my opposite sides are congruent, and C to N is 35, what is T to R? Okay. In a rectangle, this is different than a parallelogram, okay? Parallelogram merely bisects the diagonals, merely splits them into two congruent parts. But in a rectangle, the diagonals are congruent to each other. Okay? So if NT is 58 in total, well, first off, that would mean that T to E is congruent into E. So DJ, what is half of 58? 29 here and 29 there. Well, CR has to be congruent to 58, which means that if I split it in half, what is C to E? 29. Okay. All right. Those are just the properties of a rectangle. All I did there. It's kind of confusing, but you'll pick up on it rather quickly. I didn't ask that. We will learn how to do that. Okay? We will learn how to do that, but I didn't ask that just yet. Says DJ. All right? Let's do these two. I like it. It's a rhombus. It's a rhombus. Are there right angles? There could be. If it's a rhombus that has right angles, what do we call it? A square. Very good. See, we're picking up on this. Here we go. A couple minutes. Figure this one out. What's the definition of a rhombus? The what? The sides are congruent. The sides are equal. So this side equals this side equals this side equals this side, right? I'm asking you to find this side. Guess what? It's going to be the same as this side. Same as this side. Same as this side. What's the definition of a rhombus? 4 equal sides. 4A minus 14 equals 3A. Now, this is where this is where some of you would get confused. Subtract 4a from both sides. Taylor, 3 minus 4 is what?
Negative 1a.
Perfect. Taylor, what do I do to get rid of that negative 1?
You have to divide negative 0 on both sides.
Perfect. I like the wording. So what is each, well, no, that's not true. What is the value of a? 14. So is 14 my answer?
No,
Oh, what do I do with it?
I don't know.
What's 3 times 14? 42, guys. Okay, 42. Yeah, you gotta be able to count like that to be a VA. Okay. So let's know. Coach, how far are we now? How far are we now? We got 42 points. How many scores is that? 6. Good work.
I know that. You said 49.
All right. And then we got to find the measure of QRP. Notice what angle this is. Right there, right? It's not the big angle, it's the little one. Okay. How would I get it? Well, I think about this. Think about the glory days. Life is easy. Q, the angle Q plus angle R would have to be 180 for supplementary. See that? If you don't see that, what's the definition of, go back. One of the properties of a parallelogram is that the consecutive angles are supplementary. So this angle, whatever it is, plus this big angle, whatever it is, would have to equal 180. Do you understand that part? If you don't get that part, you won't get any of it. Yeah. Well, 78 plus this, that's going to be 180. 78 plus angle R equals 180. Subtract 78 from both sides. Angle R, the big angle, is 102. The whole thing is 102. Well, I want the whole thing. No, I want how much? Half of 102, which is what? 51. Okay. So there's 51 here and 51 there. In a rhombus, the diagonals are angle bisectors. Bisect the angle. What does it mean to bisect an angle? Yes, sir. Don't believe you're right. What's 102 divided by 2? What is, I'm so on you. What is the definition of an angle bisector? It's not on today's board.
That's here.
Okay. So some of you are wondering about the test. How do I get my grades better? How do I do better on the test? Get your vocab down. You're gonna hear things like angle bisector, perpendicular bisector. You got to know what that means. We've given you hints the whole year. What would happen if a bisector walks into the room? Yeah, you cut something into two, right? Got me? Two. It's really nice. It's two equal things. Okay? Bisector. Sector. Yes, sector. Okay? That's how I get that.
So if
Right.
you say plus 178 is that also, but you know that would be wrong. You don't do that.
Okay. Take a step back.
I put for a
3-minute break. I got a 3-minute break. Try and go fast. Go fast, go fast, go fast. All right. Don't worry about writing this down. Please don't worry about writing this down. If you just look at me, you'll get it. I promise. If you pay attention right now and you're not on your phone in the back of the room, then you're going to be okay. Here's the principle. If one angle of a parallelogram is a right angle, then it's a rectangle. One right angle in a parallelogram. It has to be a parallelogram Okay? Got me? It's got to be a parallelogram. There's just one angle in a parallelogram is a right angle, and the whole kit and caboodle is. Here's why. If just one of these is a right angle, remember, if it's a parallelogram, the opposite angles are congruent. That automatically makes A and C right angles. And the consecutive angles are supplementary. So C plus D would have to be 180. 90 plus 90 is the only way to get to 180. Okay? One angle is the right angle in a parallelogram. We'll work on this, by the way. If the diagonals of a parallelogram are congruent, then I have a rectangle. So this is kind of what we were just discussing on the side board over here. If AC is congruent to BD, if it's a parallelogram, get this. If it's a parallelogram, this is already true because it's a bisector already. Okay? Right? Diagonals are already a bisector. That means it's already cut into congruent parts when you get it. Okay? But if you figure out that these, BD and AC, are also congruent to each other, then you can go ahead and conclude that it's a rectangle. Why is that important? Rectangles have how many angles? And those angles are all what? And they're all congruent what? Not right angles, right angles. Okay, that's why it will be important to you. Because then you can go ahead and say, wonderful wizard, I now have 4 right angles in there. Okay? Got me? So that one's pretty crucial. Okay? Alright, here's a couple more. Rhombuses. One pair of consecutive sides of a parallelogram are congruent, and the parallelogram is a rhombus. Right? All that means is this. If I'm looking at just the consecutive sides, HE and EF, if somehow I can conclude that HE is congruent to EF, I can go ahead and conclude it's a rhombus. If I'm starting out with the fact that it's a parallelogram, remember, this all goes back, and this is why yesterday's lesson was so important. Those 5 principles that we talked about. Opposite sides are congruent. That's given already. Okay? You figure out that the consecutive sides are also congruent, and all the 4 sides are congruent to each other. If the diagonals are perpendicular, if you get this 90-degree angle right there in the middle, right, where my bisectors, got me? My diagonals bisect each other. If they are perpendicular, you have a rhombus. Congratulations. If one of them bisects a pair of opposite angles, you have a rhombus as well. So if somehow I can conclude that these angles are congruent to each other, also have a rhombus. Okay? Lots of principles involved with this stuff, right? There's like so many properties going on that I don't know how I'm ever going to get it. You'll pick up on it. You got to work through it a little bit. You got to pick up on it. Okay? Check this one out. Carpenter's square can be used to test an angle is a right angle. How could the contractor use a Carpenter's square to check if the frame is a rectangle? How do I know that it's a rectangle? Well, check it out. Both pairs of opposite sides are congruent, so it's a parallelogram. Okay? Starting off here. XY and WZ are congruent. YZ and XW are congruent. That tells me it's a parallelogram. We can set one of the squares to see if I have a single right angle. Remember, this is the first one we talked about. If one of them is a right angle, then I have a rectangle. Okay? That's the purpose of a square. I mean, even Carpenter's work. Right? You got a square. I mean, that's like, it's like normal talk, right? You got to get a side square. You have to get every side square. I mean, Jordan. So that's how, you know, you can be sure about these things. Okay? All right. let's do these, let's get this done real quickly. I know that AB is congruent to BC, is congruent to CD, is congruent to DA. So I got this right here. What figure do I have right now? That's a rhombus right now, correct? What information would help me conclude that this is a square? All right, now, check it out. That's a trick question somewhat, right? How many of those angles must I need to prove that I have all four? One. Listen. If this is a rhombus, which it is, okay? If it's a rhombus, then it's a parallelogram, right? Remember what I just said. If just one, see y'all are acting like one, okay? If just one of these is a right angle, then all of the rest of them have to be right angles. Because it's a parallelogram. And in a parallelogram, opposite angles are congruent, and consecutive angles are supplementary. If one of them is a right angle, the other four, or the other three, have to be right angles. Okay? Where? Nope. Not at all. That again. All those congruent angles. That's the difference. Great question. But that's the difference in a rhombus and a square, right? Difference in a rhombus and a square. Okay? All right. Don't worry about this. Let's talk about it though. Nope, we're not even going to talk about it. Okay? I'm going to let you get going on your classwork. We got to get on that. Anybody